Mind, or you simply love falling asleep to the sound of science. Tonight, we sink slowly into the earth, not with shovels, but with ideas, dreams, and the deepest drill humans ever dared to turn. Picture this: a quiet tundra wind brushing gently over frost-bitten soil in the far northwest of Russia. A place so still you can almost hear the ground breathing. And then imagine a hole narrow as a dinner plate, but plunging over 12 kilometers into the planet's skin. If you enjoy these sleepy explorations, I'd be so grateful if you gave the video a little like and tapped that subscribe button. It helps more sleepy scientists like you find their way here, and it means I can keep making more of these journeys for you now. The Kola Superdeep Borehole is not something that towers like a telescope or gleams like a satellite. It is humble, just a small circle of steel surrounded by snow and curiosity. But oh, the secrets it tried to reach. It was a quiet question pointed at the earth. What are you made of, really? And the earth reluctantly answered back. You drift downward now, gently, through cool layers of crust, not falling but floating, as if carried by the slow breath of time itself. Each meter of stone has a story, millions of years, compressed into color crystal texture. You pass through granite older than bones, older than fish, older even than fungi. These are stones that remember the silence before life found its voice. In the 1970s, when Soviet geologists first began drilling here, they weren't looking for oil or gold. No, this hole was meant to be a window, not outward into space, but inward into the mystery beneath our feet. That decision alone makes it feel a little magical, doesn't it? We often look to the stars for awe, but here the awe came from within. Imagine being one of those scientists. The wind biting your coat, the northern light curling like a ribbon above you, and beneath the metal cap of the borehole, nothing but unknown. The project began in 1970, and by 1989 they had reached an astonishing depth, 12,262 meters, just over 7.6 miles. That's deeper than the Mariana Trench, deeper than any mine, deeper than anything humanity had ever touched. And all of it carved slowly through rotating drills, breaking bits and dreams. At its deepest, the pressure was over 630 times the atmospheric pressure at sea level. Temperatures reached 180 degrees Celsius, nearly double what engineers had anticipated. You pause here. Let that sink in. The team thought they were only drilling into rock, but they were also drilling into assumptions. The Earth, it turns out, is not always what we think. And despite the impossibly narrow shaft, the borehole wasn't just about depth, it was about listening. Sensors were lowered. Cores were pulled up. They were reading the planet like Braille, line by line. And every core sample was like a message in a bottle, from a time before time. Have you ever held a rock and wondered what it's seen? Now picture holding a rock that last saw sunlight 2.7 billion years ago. As you float deeper through this mental descent, imagine the Earth not as a passive shell, but a layered cathedral. Each stratum a choir humming softly in mineral tones. The granite sings low, the schist whispers, the basalt murmurs in heat. Every vibration, every echo through the stone is a story. And the Kola Borehole, in its quiet persistence, began to hear them. But it wasn't easy. The deeper they went, the stranger things became. Drilling would stall unexpectedly. Equipment would buckle. Instruments would fail in the intense heat and pressure. It's as if the Earth was gently resisting, pressing back, like a sleepy blanket refusing to be pulled down. And still they kept going. Have you ever wondered what the Earth might say if we could speak its language? What secrets lie folded in its layers, like pages of a forgotten diary? This hole, just a narrow shaft in a remote corner of the world, tried to read that diary. And as you hover here, suspended in quiet wonder, above the dark mouth of the Kola Borehole, you begin to feel the gravity of it, not just physical, but emotional. This isn't just geology. It's a story of patience, curiosity, and the soft persistence of those who chose to look inward when the world was busy looking up. You rest here now, drifting between curiosity and calm, surrounded by the memory of granite, the hush of deep time, and the warmth of a hole that touched the planet's bones and came back changed. You continue downward now, gently rotating like a leaf, falling through space deeper into the quiet puzzle of the Earth's crust. The layers around you aren't just rock, they're like tightly wound scrolls holding the untold story of a planet that's been writing itself for over 4.5 billion years. And now you're gliding through one of the rare places where humans dared to crack that scroll open. The Kola Superdeep Borehole wasn't the deepest hole in terms of distance from the surface. After all, the oceans have their trenches, but it remains the deepest artificial point ever reached through dry land. The goal wasn't to reach the center of the Earth. That would be impossible with current technology. No, the mission was to go as far as our tools and our patience would allow. And so, bit by bit, they dug through what geologists call the continental crust, that outer layer of Earth, which forms the bedrock beneath our feet, beneath cities, forests, and entire histories. The deeper they drilled the stranger, it became not just scientifically, but structurally. The equipment itself became something of a character in the story. The drill bits at the heart of the project were no ordinary tools. They had to endure unbelievable stress, rotating continuously at high speeds, pushing through materials that had been compacted and hardened for billions of years. As they turned, they heated from friction. The rocks pushed back not violently, but with slow, relentless pressure. A kind of silent protest. The deeper the hole became, the more the equipment had to be reinvented. You might imagine this drill like a brave little worm nibbling its way downward, undaunted. And in a sense it was. Except this worm had sensors, temperature gauges, tensile strength monitors, pressure limits. Every inch gained was earned with sweat and calculation. Here's something curious to picture. The diameter of the Kola borehole was only about 23 centimeters, roughly the size of a dinner plate. That's it. A hole barely big enough to fit your head through, yet it stretched for over 12 kilometers downward. A tunnel you could never climb into, but one that has touched places no human hand ever will. Now float alongside the timeline. When drilling began in 1970, the original plan was to reach a depth of 15,000 meters, or about 9.3 miles. Scientists believed it could be done within a couple of decades, but the Earth had other plans. As the drill reached deeper levels, temperatures climbed higher than expected. At around 10,000 meters, sensors began to record over 180 degrees, far above the predicted 100 degrees C. That may not sound catastrophic, after all, ovens get hotter, but imagine drilling through rock that is effectively slowly melting, deforming under pressure, and trying to squeeze your delicate instruments like dough in a vise. And then came the rock formations. Deep down, the drill hit metamorphic schist rocks formed under immense heat and pressure. These were not friendly layers. They were brittle in some places, pliable in others. They cracked unpredictably, or worse, they flowed like plastic, closing in around the drill shaft like a slow geological hug. This wasn't the solid bedrock scientists had expected. It was something stranger, almost alive in its resistance. Let yourself feel that sensation for a moment, a narrow drill surrounded by searing hot, ever-shifting stone, being swallowed by a crust that had not been disturbed in billions of years. It's like threading a needle through lava. As you drift deeper into the story, ask yourself this: how much can we really know about the world beneath us when the very act of touching it changes it. The scientists working on the borehole faced constant setbacks, equipment failures, misread data, unexpected formations. But perhaps the biggest challenge was mental. The project took nearly 2 decades to reach its final depth. That's 20 years of waiting, watching, recalculating, trying again. Imagine showing up to the same icy compound in Murmansk every winter, the cold biting your fingers as you run diagnostics, listening to the quiet hum of the drill motors, knowing that you might only gain a few dozen meters this season. And yet you come back, because something down there is calling. This wasn't flashy science. It was quiet, incremental, almost meditative. And that's part of why it's so beautiful. The idea that we would dedicate decades' careers to drilling into the earth, not for gold or oil, but just to know, is something you might find surprisingly comforting. It reminds you that curiosity doesn't always need to explode with fireworks. Sometimes it just hums softly beneath the soil, asking politely to be heard. You continue your gentle descent, now deeper into the crust than most rocks will ever go. Around you, the color shifts gray to darker gray, speckled with veins of quartz and feldspar. You can almost feel the density increasing, like walking into a thicker silence. There's no sunlight here, no sound save the slow settling of stone. But there is warmth, a kind of internal fire coiled in every mineral, like a sleeping dragon. And it's that fire, the geothermal gradient, that pushed back against the drill, whispering not so fast. It was that resistance that eventually brought the Kola Borehole to a halt, but not before it had rewritten more than a few textbooks. We'll get to that soon. For now, just enjoy the hush of this place, a tunnel into the bones of the planet, not carved by time, not hollowed by erosion, but made by human hands reaching inward with wonder. Deeper still you go, no jolts, no sudden shifts, just a soft, spiraling descent into the Earth's quiet heart. The warmth becomes more noticeable now, not an aggressive heat, but a slow rising whisper wrapping around your arms like a heated blanket. And with it, a new sensation, resistance, not from the motion, but from the Earth herself, who seems to be watching your progress with an amused patience. When the Soviet scientists reached the depths of around 7,000 meters, they encountered something that changed the tone of the entire project. It wasn't just rock down there. It was heat. A lot of heat. See, the team had predicted certain temperature ranges based on models of how heat radiates from the Earth's core. But the further they drilled, the more the numbers began to disobey. At around 10 kilometers, temperatures shot up unexpectedly, reaching about 180 degrees Celsius. That's 356 degrees. Nearly double what they had projected. And with that heat came a host of complications. Metals expanded. Lubricants failed. The drill pipe warped under thermal stress, like trying to cook a delicate souffle inside an engine block. Not ideal. Ask yourself this: what would happen to metal gears and rotating shafts when they're exposed to temperatures usually reserved for baking bread? The answer is, they bend, they fail, and they become unpredictable. Machines built for room temperature were now being tested in conditions more suitable for volcanic kitchens. Even more intriguingly, this unexpected heat revealed something profound. The assumption had been that as you descend into the Earth, the increase in heat would be relatively gradual. But that assumption, like many in deep geology, began to crack under the weight of new data. And then came the rocks themselves. The drill cut through granulite gneiss, a type of metamorphic rock formed under incredibly high pressure and temperature. But here's the curious part. These rocks had fractures filled with gas and mineral fluids, signs of ancient chemical activity that no one expected at this depth. It was like finding fingerprints on a locked vault. The deeper they went, The more those fractures multiplied, each one a soft whisper from the past, reminding us that Earth's crust is not a static cake layer of stone. It's dynamic, restless, textured with time. Now imagine being one of the scientists lowering sensors into the abyss day after day, each time hoping for clean, stable readings. Instead, you get echoes, fluctuations, tiny voices of heat and pressure murmuring through the instruments. What if the Earth isn't just layers of matter, but something more alive, always shifting, stretching, pushing back? The engineers started to face a new kind of opponent, the rocks themselves. Because down here, something peculiar was happening. The rocks weren't behaving the way solid rock is supposed to behave. Instead of being rigid, they were plastic. Not in the artificial synthetic sense, but in the way they slowly deformed, flowing almost like honey under pressure. You float beside these deformed rocks, now trailing your fingers across ancient folds. They curve like ribbons, like frozen waves caught mid-crash. They tell you stories of continents that collided and mountains that folded like napkins under the press of tectonic force. This region beneath the Pechensky district of Russia used to be at the heart of ancient plate collisions. About 2.7 billion years ago, this crust was part of something unimaginably different. Maybe part of a microcontinent, maybe ocean floor now uplifted. The rocks don't give exact answers. They prefer riddles. And riddles, you'll find, are the Earth's favorite language. Pause here. Picture that rocks flowing like taffy under invisible pressure. Instruments gently bending like hot wax, and above you a drill pipe stretching kilometers toward the surface, trembling ever so slightly with each movement, like the thread of a spider web dipped in lava. It's almost poetic, isn't it? This technological ballet between humans and geology. Despite these challenges, the drilling continued. Reinforcements were made. Materials were improved. But they could never fully beat the heat. And eventually that became the quiet villain of the tale. Heat that made drill bits crumble like dry cookies. Heat that warped data. Heat that said you've come far enough. Still, those layers yielded secrets. Tiny fossilized plankton shells were found at 6.7 kilometers, impossibly ancient microfossils preserved in metamorphic rock. Life clinging to memory, even beneath crushing pressure. What were they doing there? How did they survive the heat and metamorphosis? Let yourself wonder that. How far beneath the surface can the fingerprints of life remain? Is the Earth littered with these echoes, just waiting for us to find the right drill, the right angle, the right story? There's something oddly comforting in that. Knowing that life leaves traces not just on the surface, but in the folds and fractures of stone. The deeper the borehole reached, the clearer it became that the Earth would always have more mysteries than answers. The crust wasn't a simple layer of rock, but a chaotic ancient mosaic. Pieces older than bones, older than bacteria, older perhaps than the idea of time itself. And so you drift side by side with these whispering stones, every meter a story, every fracture a scar, every heat burst a reminder that we are guests in a world much older than we can ever grasp. You drift now into a depth where silence becomes richer, thicker. The air, if there were any, would feel syrupy with pressure. Around you, the walls press closer, not in menace, but in a quiet kind of welcome, as though the planet herself recognizes your descent. You've passed through layers that have not stirred in hundreds of millions of years, and now you reach the places where even the imagination slows down, unsure how to picture what comes next. This is where things begin to get strange. At around 12 kilometers deep, the Kola Superdeep Borehole reached what would ultimately be its final depth, 12 to 62 meters, or just over 7.6 miles. To this day, no borehole has gone deeper through the Earth's crust. But here's the surprise: it wasn't mechanical failure that stopped the drilling. The machines could have kept going. It was nature's quiet defiance. Temperatures had risen to over 180 degrees, well beyond expectations. The rocks weren't behaving. They were no longer the brittle formations scientists expected to find. Instead, they were softer, more ductile, less like rock, and more like a sort of hot, pressurized clay. Drilling through them was like pushing through warm fudge with a plastic straw. Why would rock, something so solid and unyielding, melt into pliancy under your hands? Well, pressure changes everything. These deep rocks are compressed under the weight of kilometers of crust above them. That weight doesn't just sit, it crushes it, squeezes it, alters the very structure of the minerals. Combine that with extreme heat, and suddenly the familiar becomes alien. What was once granite becomes something more akin to wax, unwilling to hold its shape, prone to folding and flowing. And this is what finally stilled the drill. It wasn't that the drill snapped or the crew gave up. It was that the rocks stopped cooperating. They refused to break cleanly, refused to obey the tidy models printed in geology textbooks. They became, in a way, the main character, one that refused to be written. Now you float at that final depth, hovering at the threshold of what we've reached, the end of the line. Below you there is only unknown. Let your imagination stretch downward. What lies just a few hundred meters deeper? 1,000. Will the rocks continue to melt into softness? Will the heat become unbearable? Or will the unexpected arrive, pockets of gas, or deep biospheres or minerals that sparkle in ways we've never seen? The truth is, we don't know. And maybe that's what makes this depth so special. Not because it's the deepest place we've been, but because it sits right on the edge of what we've touched and what we haven't. Let's return to the borehole itself for a moment. Though its diameter was narrow, just under 9 inches, scientists packed it with sensors, equipment, hopes. The borehole was more than a hole. It was a messenger. A long, narrow antenna pressed against the heartbeat of the Earth. And what it told us wasn't just about geology. It changed our assumptions about the very structure of the crust. Prior to Kola, scientists believed there was a clear boundary between granite and basalt, two key types of rock in Earth's crust at around 7 kilometers deep. Seismic readings from earthquake waves suggested a change in material at that level. But when the drill passed that point, it didn't find basalt. It found granite. Still. So where was the boundary? Was there one, or had we misread the signals from our seismic experiments? It turns out the changes in seismic waves weren't due to different types of rock, but rather changes in the structure of the same rock caused by heat and pressure. In other words, the rocks were whispering in frequencies we misunderstood. What does that mean? It means that even our most confident predictions, our deepest models, can be gently disproven by a narrow shaft of steel and sensors. It means the Earth still holds secrets close to her chest, and it means that science, like sleep, is about learning to rest inside mystery. Pause for a moment. Take a slow breath. The rocks around you are ancient. Some of them date back more than 2.5 billion years. They've seen supercontinents form and fracture. They've felt the weight of oceans above them. They've been pressed and stretched, transformed, again and again by time and heat. Now they cradle this borehole like a tree, wrapping around an old fence post. And yet even here, in the deepest man-made hole on Earth, there are signs of life. Not current life, but ancient fossilized microorganisms, tiny shells, wisps of carbon. Marks left by creatures that lived long before dinosaurs walked the land. These are not fossils you would find in a museum, polished and labeled. These are deep, compressed echoes, like the fingerprint of a ghost on a windowpane. And they ask you, How far can life reach? Could it survive even deeper? Could it be hiding in hot pockets of water, in cracks too small for us to see? In recent years, other boreholes not as deep, but drilled with different goals, have found microbes living kilometers below the surface. These deep biospheres, as they're called, are still being studied. But they suggest something astonishing, that Earth's crust might not be a dead shell, but a vibrant secret ecosystem. So maybe the Kola borehole didn't reach the center of the Earth. Maybe it didn't pierce the mantle. But it did something just as profound. It showed us how little we know. It opened a door, not to the molten core, but to humility. You hover now at this final point, not with frustration, but with awe, because sometimes the most powerful discoveries are the ones that tell us to keep dreaming. Now the drill is still, the machinery silent, but the Earth is not. You continue your quiet journey downward, past the point where human hands and machines turned back. There's a hush here that feels sacred, as if the planet is exhaling in long, slow sighs through the pores of her deepest skin. The rocks here are so compressed, so ancient, that they hardly feel like rocks anymore. They hum with memory. And now, drifting just beyond where the Kola Superdeep Borehole ends, you're entering territory no human drill has touched. But imagination has. Theoretical models have been built for this place, based on pressure curves, heat gradients, and seismic shadow zones. Here is where the crust transitions toward the mantle, and where things get truly strange. Imagine slicing the Earth like a fruit. The crust is that thin outer layer, about 5 to 70 kilometers thick, depending on whether you're under ocean or continent. Beneath it lies the mantle, which makes up over 80% of Earth's volume. But the boundary between the two, the Mohorovičić discontinuity or MOHO, is not a hard line. It's a blurred zone, a melting between identities. At the MOHO, rocks begin to change chemically. Pressure and temperature increase rapidly. You're entering a place where peridotite, a greenish rock rich in olivine, starts to dominate the scene. It's heavier, denser, and slowly moving, creeping like a glacier of stone. Personify it for a moment. This rock is not hostile but purposeful. It flows in geologic time. Imagine a stone with the patience of mountains, the slowness of dreams. This is the deep earth, steady, wordless, contemplative. And it's not empty. Far from it. Here mantle plumes may begin their long, slow rise. Picture them like candle flames, frozen in motion. Columns of hot rock moving upward over millions of years. These plumes give birth to volcanic islands like Hawaii. They leave trails like cosmic fingerprints across the ocean floor. They begin perhaps here, just past the crust's edge. So what lies below the Kola borehole, beneath that final meter of drilled stone? A dynamic, restless layer. Temperatures spike to over 400 degrees C, just a few kilometers deeper. Pressure rises to over 3 gigapascals, roughly 30,000 times atmospheric pressure. Under these conditions, rock behaves neither like liquid nor solid. It oozes, slowly, painfully, elegantly. Ask yourself, what does time feel like to a rock under that kind of pressure? It might feel like nothing, or everything. Seismic waves, the tremors from earthquakes, and man-made blasts have given us hints about this hidden world. They speed up or slow down, depending on the material they pass through, creating echoes that geologists read like sonar. These echoes have revealed subduction zones, where oceanic plates dive deep into the mantle. They've shown us slabs of crust that still descend hundreds of kilometers down, refusing to melt completely. Picture them as fossil rivers of stone, plunging into fire but never disappearing. The region just beneath the crust also holds tantalizing possibilities. Could there be water, locked inside minerals down here? Some studies suggest that the Earth's mantle may contain more water than all of Earth's oceans, combined not in lakes or streams, but in the crystalline structure of olivine and wadsleyite. Water not flowing, but hidden, whispering, waiting. Let that idea settle in your mind. For a moment, the earth not dry and cracked inside, but damp at heart. Moisture held tight in rock released only under extreme pressure or heat. A planet with a secret ocean not above, but within. So what else is stored down here? Diamonds form in these depths. Real ones. Most natural diamonds come from about 150 to 200 kilometers deep. They form under intense heat and pressure, then rise quickly to the surface in volcanic pipes. But many never make it. They remain trapped in the dark, their brilliance unseen. Perfect silent geometries that no one will ever find. It's comforting, isn't it? Knowing that the earth makes beauty just for itself. That somewhere deep below your feet, there are flawless diamonds glinting in the darkness, like stars that chose not to shine. As you move gently through this imagined space, remember, the Kola Borehole didn't fail. It reached the point where questions became more valuable than answers. Where heat, pressure, and fluid rocks whispered, "Not yet." You're close, but not yet. You leave that depth behind, now drifting slightly upward. Not backtracking, but exploring sideways, imagining the crust, not as a line, but as a landscape. Full of faults, ridges, slabs, and hidden chambers. This crust, after all, is not uniform. It varies wildly from place to place. Beneath ocean basins, the crust may be only 5 to 10 kilometers thick, young, dense, and born from mid-ocean ridges, where magma wells up like glowing syrup. But under mountains like the Himalayas, the crust thickens to over 70 kilometers, crumpled like a rug shoved against a wall. Why does the earth wrinkle like that? Because the plates are always moving, always pushing, always cracking and subducting. A slow tectonic waltz. Sometimes two continents collide, and neither gives way. So they fold buckle and build mountains that scrape the sky. That's where crust thickens. That's where you get roots, massive deep keels of continental crust that extend downward like inverted mountain ranges. And those roots, too, are full of stories. Imagine being a grain of quartz trapped for 1 billion years, buried deep within a mountain root. Watching eons pass, volcanoes rise and erode, oceans form and vanish, dinosaurs come and go. And through it all, you just sit quiet and still, until maybe one day, a geologist picks you up, polishes you, and asks, "Where have you been?" There's something very human about wanting to understand the earth from the inside out. It's like wanting to know someone deeply, not just their words, but their silences, not just their skin, but their bones. That's what the Kola Borehole offered us, a conversation with the bones of the world. And even if it didn't go all the way through the crust, it went far enough to say there's more down here than we ever imagined. Heat, yes. Strange rocks, yes. But also fossils, fluids, fractures, echoes of continents past, and maybe the faint scent of water and the distant shimmer of unfound gems. Your mind floats now like a feather, caught in warm currents, drifting deeper into the slow heartbeat of the earth. You've seen the limits of the Kola Borehole and imagined the invisible landscapes beneath it. Those gentle folds of rock, soft with heat and pressure. Those diamond-studded corridors where time no longer keeps track of itself. But what of the people who created the hole? The hands that turned the drills, the minds that dared to reach downward. Their story is quieter than the Earth's, but no less fascinating. The drilling of the Kola Superdeep Borehole began in 1970 during the Cold War. But unlike the space race or nuclear arms buildup, this was a competition far from the public eye. The Soviets weren't trying to beat the Americans to a moon landing this time. They were trying to beat them to the center of the Earth, or at least deeper than anyone had gone before. It was a race of depth, not distance, a contest not fought in skies or speeches, but in rock heat and patience. You might imagine rows of computers whirring quietly in Soviet labs. Engineers hunched over blueprints, whispering calculations. But at the heart of it was something more: elemental curiosity, the simple, stubborn human urge to know what lies beneath. The drilling site was located on the Kola Peninsula, far in the northwest of Russia, above the Arctic Circle. An area so cold, so wind-bitten, that even machines sometimes refused to start in the morning. The site was remote, chosen for its thick crust and relative geological stability. And then, the work began. Years passed, decades even. Engineers developed new drilling technologies like specially designed turbo drill bits and drill string stabilizers that could survive extreme depths. By 1989, after nearly 20 years of drilling, the project reached its maximum depth, 12,262 meters, or about 40,230 feet. To compare, that's deeper than the Mariana Trench is below sea level. You could stack Mount Everest 1.5 times inside that hole. Now imagine being one of the scientists on site the day the drill reached its final meter, watching the temperature gauges spike unexpectedly, feeling the walls of the hole begin to misbehave, not from any error, but because the Earth simply refused to act as predicted. The rocks, now behaving more like plasticine, began to flow inward. The hole started to close in on itself, not violently, just insistently, as if the planet were gently saying, "That's far enough, little one." And perhaps it was. But this journey wasn't a failure. Far from it. In fact, many of the most unexpected and fascinating discoveries came not at the final depth, but all along the descent. For example, scientists were astonished to find water-free water trapped in deep rock formations over 7 kilometers down. This wasn't surface water seeping in. This water had likely been formed chemically deep within the Earth's crust itself and trapped there for millions of years. Think about that for a moment. Drops of water untouched since before the rise of mammals, resting in stone. What might that water have whispered if you could hear it? What stories would it tell, sealed away for eons until a drill brushed its prison wall? The borehole also revealed fossilized remains of plankton, not in the expected shallow marine rocks, but deep below the surface. Tiny organic remains embedded in ancient metamorphic rock far from sunlight and time. Their presence upended our assumptions about what life could survive and how far it could be buried by the shifting crust. And then there was the absence. Remember the supposed granite-basalt boundary, that seismic trickster we spoke of earlier? The Kola Borehole revealed that the change in wave speed was not due to a change in rock type, but a change in physical properties caused by heat pressure and fluid content. This meant that many seismic interpretations around the world had to be revised. The Earth, it turned out, was subtler than we thought. It didn't always color inside the lines. Ask yourself, how many other assumptions are we making now, quietly, confidently, that will someday be upended by a single curious hole in the ground? That's the thing about drilling. It isn't just about rock and dust. It's about uncertainty, slowly peeled back like layers of sleep. And now, let yourself descend again, not through rock, but through the idea of depth itself. What is it that draws humans downward, into caves, into mines, into stories about hidden kingdoms and underworlds? Maybe it's the sense that something essential is buried, that to understand the world you have to go not outward but inward. Down here in this imagined shaft of steel and silence, you begin to realize something. The further we go down, the more the lines between science and wonder blur. Rocks aren't just rocks, they're storytellers. Pressure isn't just a measurement, it's a sculptor shaping reality. And time doesn't pass. It pools, it waits, it holds its breath. Back on the surface, the Kola Superdeep Borehole is now sealed. A rusted metal cap about the size of a manhole cover marks the spot. You could walk right over it and never know what lies beneath. No sign, no ceremony, just a quiet portal to Earth's forgotten chapters. And maybe that's fitting, because the borehole was never meant to be flashy. It was a question, not an answer. A gentle tap on Earth's shoulder. "Hey, what's down there?" And the Earth replied not with words, but with heat surprises and more questions than we knew how to ask. Let those questions swirl around you now. What lies deeper than the deepest thing we've touched? Could life exist there? Could energy movement or memory be etched into the layers we haven't seen? You hover in the stillness of these thoughts, wrapped in the dark velvet of deep time. The deeper you go, the slower everything becomes, even thought, even breath. And in that stillness, the world starts to make a different kind of sense. You stay with that stillness for a while, cocooned in the warmth of pressure and time. The deeper you go, the gentler everything becomes. No sudden movements, no rush, just the slow inhale and exhale of a planet that's been breathing for billions of years. The Kola Borehole may have stopped its descent, but your imagination keeps burrowing deeper than any drill guided only by wonder. Now let's explore one of the most fascinating parts of this journey, what wasn't found. Because sometimes absence is more mysterious than presence. Picture this: a scientist sitting in the chilly control room above the Arctic Circle reviewing samples from kilometers down. They were expecting to find something, maybe even certain gases or minerals, but what they encountered instead was a silence. The kind of silence that makes you lean in. One of the biggest surprises came in the form of heat. The deeper the drill went, the hotter the rock became, far more than calculations had predicted. At the maximum depth, the temperature was about 180 degree or 356 degree, so hot that the rock was almost behaving like plastic, slowly flowing instead of staying solid. Now think about that. Solid rock softened by heat and pressure, warping time like a Dali painting. The drill bit wasn't just boring through stone, it was negotiating with it, tiptoeing through material that was very much alive in its own slow-motion way. This unexpected heat made further drilling nearly impossible. It was as if the Earth was pushing back, whispering, "Not just yet. You're not ready." That's one of the subtle truths unearthed by the borehole. The more we learn about our planet, the more we're humbled by how dynamic it is. We tend to think of rock as the definition of stillness, the essence of silence. But down here, silence is an illusion. Heat hums, minerals rearrange. Crystals grow at a glacial pace, threading themselves into complex lattices. Ask yourself, what would it feel like to be a crystal, forming one atom at a time over 1,000 years? What if the Earth isn't asleep, but dreaming? Another eerie discovery came from the acoustic realm. Deep in the borehole, the drill began to pick up strange sounds, not voices, not language, but groans and creaks that seemed to rise up from the rock itself. These were likely just the natural noises of thermal expansion, geological shifting, or equipment strain. But to the scientists listening, there was an unmistakable feeling the Earth was speaking. Of course, newspapers at the time ran wild with rumors. Some claimed the Soviets had drilled into hell, reporting screams and supernatural happenings. But while those tales were sensationalized fiction, they were rooted in a strange truth. When you descend that far into the Earth, you are stepping into the unknown, a realm not made for human senses. And your imagination, like a diver at dusk, starts to see shadows. It's here, too, where scientists found layers of metamorphic rock that told a time-bending story. Some rocks pulled from over 6 kilometers down were dated to be 2.7 billion years old. That's nearly two-thirds the age of the Earth itself. They sat there patiently, holding their breath, waiting for someone to ask the right question. And here's a sleepy question to let swirl in your mind. What would a 2.7 billion-year-old rock remember? Would it speak of forming continents? The rise of oxygen in the sky? The slow parade of life creeping from sea to land? Within those rocks there are tiny grains of zircon, which scientists use as nature's time capsules. Some zircons contain tiny amounts of uranium, which decay into lead over time. By measuring that decay, scientists can tell just how old the crystal is. It's like the Earth tucking little notes inside itself, open in a few eons. Love the universe. And tucked within those layers were fossilized microorganisms, single-celled plankton from long-forgotten seas. Not large or flashy, but resilient. Their cell walls had survived pressure heat and time to whisper across the millennia. We were here. Imagine those tiny creatures now floating gently in the oceans of a primordial Earth long before anything had crawled onto land. Now imagine them fossilized, deep in rock, drifting once again, this time upward on the tip of a drill. So many voices, so many stories. Some in layers of granite, some in heat, some in the sound of rock stretching under strain. Each one asking gently, "Are you listening?" By now you may feel like you've descended with the borehole, not just physically, but mentally. Everything slows in this world. Time unfurls like ribbon. Even your thoughts begin to stretch, bend, soften. And in this dreamy state, another image forms the Kola Borehole, not as a machine or a Soviet relic, but as a thread, a single slender filament tying the surface to the deep. How many such threads does our Earth carry? Could there be other holes, other passages we haven't yet discovered? What if Earth has hidden networks? Secret seams stitched through the mantle, formed long before we ever thought to measure them. You drift in these thoughts, like silt settling at the bottom of an ancient sea. Weightless quiet suspended between science and dream. Above the surface is a distant memory. Below the core is still unimaginably far. But right here, just above the middle, you're held in the arms of mystery. A place where pressure hums stones, whisper, and silence is never truly silent. You continue drifting, suspended in this slow-motion fall toward the center of the Earth, where time doesn't tick. It hums. The Kola Borehole may be sealed, but in your imagination, the descent continues. Softly, deeply. The weight of rock above you presses gently, like a weighted blanket made of continents and eons. And beneath you, the unknown is still unraveling. Now let your thoughts settle around an extraordinary idea, the Earth's mantle, the layer beneath the crust, which the Kola Borehole didn't quite reach. It's not because the scientists lacked ambition, but because reality set its own boundaries. The crust at the borehole site is roughly 35 kilometers thick, and even after 2 decades of drilling, they had reached only about a third of the way. So the mantle remains untouched, unseen, imagined through seismic echoes and creative thinking. But let's go there in your mind. The mantle is not some bubbling cauldron of lava, as cartoons might have you believe. It's more like a solid that flows slowly and patiently over geological time. Like honey stored in a cold cave or warm caramel stretched over millennia. It makes up 84% of Earth's volume, yet we've never held it in our hands. Just pause and imagine that most of the planet beneath your feet has never been touched. Isn't that wild? The mantle begins just beneath the crust and stretches down 2,900 kilometers, where it kisses the outer core. In this vast region, temperature climbs from about 500 degrees at the upper boundary to 4,000 degrees C near the bottom. That's hotter than the surface of some stars. But under pressure, even rock behaves like a slow, sticky fluid. It's here in the upper mantle, where mantle convection takes place, a slow-motion dance of rising and falling material that drives plate tectonics. This invisible engine powers earthquakes' mountain formation and the drift of continents. Picture it, entire continents riding on the backs of these swirling currents, like lily pads on a very, very slow whirlpool. You might ask yourself, what does it feel like to be a continent? To drift through deep time nudged by heat and mineral breath. The Earth's crust is like skin, thin, cracked, and sensitive. But the mantle, that's where the real strength lies. It holds the shape of the world, carries the memory of collisions, and breathes its slow heat toward the surface. We can't drill there, not yet. But seismic waves allow us to listen to it. When earthquakes ripple through the earth, their waves bend, reflect, and refract depending on the materials they pass through. Like sonar through a sleeping ocean. By listening closely, geophysicists can map the invisible, like sculptors, working blindfolded, shaping a model of Earth's interior through vibration alone. And what do these echoes tell us? They speak of mantle, plumes, columns of hot rock rising toward the surface, fueling volcanic hotspots like Hawaii or Iceland. These plumes rising from deep within the mantle are Earth's way of exhaling. Imagine them as vast, silent geysers of heat, lifting mountains and islands as they go. They tell us, too, of subduction zones, where old ocean crust is pulled downward into the mantle and recycled. Earth, it seems, is a tidy creature, cleaning up its mess, reinventing its layers, like a snake shedding its skin in the dark. And then there's something called the mantle transition zone, found between 410 and 660 kilometers deep. In this region, high pressure causes minerals to rearrange their structure, transforming into entirely different forms. It's like rock undergoing puberty, awkward, intense, and utterly transformative. One mineral in particular, olivine abundant in the upper mantle, changes into wadsleyite and then ringwoodite at these depths. These aren't just lovely names. Ringwoodite, for instance, can trap water molecules inside its crystalline structure. Yes, water. Locked inside rock. In 2014, scientists analyzing a diamond brought up from deep within Earth found evidence of ringwoodite that contained 1.5% water by weight. It might not sound like much, until you realize that the transition zone could contain as much water as all of Earth's oceans combined, hidden in solid form. This secret ocean doesn't lap at shores or sparkle under sunlight. It waits silent and unseen, tucked into rock like a memory. Ask yourself, what kind of life might exist if that water ever found a way to surface? What stories are folded into minerals never told in daylight? The deeper you drift into these thoughts, the more the mantle feels like an ancient archive. Not a library of books, but of processes, pressures, transformations. Everything that happens on the surface, the weather, the seasons, even the breath in your lungs is just the final ripple from the hidden motions below. And we know so little of it. The Kola Borehole touched just the beginning of this vast domain. It whispered against the crust, made us shiver with curiosity, and then fell quiet. But the story didn't stop. Other nations have tried too. Japan's Chikyu project aimed to reach the mantle through the ocean floor, where the crust is thinner, only 5 to 10 kilometers thick in places. But no attempt so far has succeeded. Maybe someday we'll get there. Maybe someone someday will send a new drill downward, bearing a camera, a thermometer, and a question scrawled onto the side. What does it feel like to be the Earth? Until then, we imagine. And that's the beauty of it. The unknown doesn't push us away. It invites us gently like a parent nudging a sleeping child into a dream. So you drift now in that dream, mantle-bound, ringwoodite rich, carried on currents that take millennia to make a single swirl. The pressure around you is soft now, not frightening. It holds you like a blanket stitched from gravity and age. Nothing to fear, only questions to float in, and stories still waiting in stone, still wrapped in the warmth of those hidden oceans, locked within stone. You drift gently downward, slowly, slowly, as if gravity itself has dozed off. Your breath is calm, your thoughts unhurried. The surface world has disappeared completely, now muffled by kilometers of crust, forgotten like a half-remembered dream. Let's imagine then what lies beneath the mantle. You've passed through layers that shift, stretch, and breathe. You've heard the slow whisper of silicate rock. Now just ahead glows a boundary like the golden seam between day and dusk. This is the core mantle boundary, a line drawn not in stone, but in temperature and density. Here the world changes again. The rocks you've known, pressured, transformed, ancient, give way to something altogether more alien. Below is the outer core, a vast sea of molten metal. Yes, liquid metal. Mostly iron and nickel spinning and churning in a hellishly hot cauldron that spans 2,200 kilometers in thickness. It begins at about 2,900 kilometers below the surface and stretches to the very heart of the planet. But before you sink into this glowing ocean, take a moment and rest on the edge. Close your eyes and feel the heat more than 4,000 degrees C, as hot as the surface of the sun. And yet you're protected, not by gear, not by magic, but by imagination. Ask yourself this. What does iron feel when it melts in the dark, never having known a sky? The outer core is in constant motion. Its currents are driven by heat from the inner core and the cooling of Earth's surface. These movements stir up the metal like honey in a storm, and in doing so they generate Earth's magnetic field. Yes, this invisible shield that guides, compasses, and deflects solar wind, this guardian of atmospheres and auroras, comes from here. From the dance of liquid iron deep beneath your feet. It's called the geodynamo, and it's one of the most mysterious and essential systems on the planet. Without it, Earth's atmosphere might have been stripped away by the sun's radiation billions of years ago. Life as you know it, impossible. Imagine the outer core as a drummer keeping time for the whole planet. It spins, flows, eddies. And because iron is a good electrical conductor, these flowing movements create currents, and those currents create a magnetic field. No conductor, no field, no protection, no life. So here in this dark, buried ocean of glowing metal, the Earth protects its own. Now you sink farther, gently parting the molten curtain. The fluid thickens until it becomes still. You've arrived at the inner core, a solid sphere roughly 220 kilometers in radius, resting at the center of it all. Solid, yes. Despite temperatures that may reach 5,400 degrees C, the inner core remains solid because of the enormous pressure bearing down from above. Pressure so intense, it forces iron atoms into a tight crystalline embrace like dancers frozen mid-waltz. If the outer core flows the inner core rings, it may even rotate at a slightly different speed than the rest of the planet, a quiet rebel at Earth's heart. Some scientists believe it turns just a little faster, completing a lap around the Earth every 700 to 1,000 years. Now that's a slow spin, but it's a rhythm all its own. The inner core may be solid metal, but it isn't silent. Seismic waves pass through it, and by studying their speed and direction, scientists believe the core is not uniform. There may be layers within the layer, a kind of nested sphere, each one telling a different part of the Earth's creation story. And just think, we've never touched it, never seen it. Everything we know comes from echoes, from ripples, from distant vibrations translated into meaning. Isn't that beautiful? That science can see in the dark by listening instead of looking. Now imagine standing figuratively on the edge of that solid heart. You are surrounded by molten fire wrapped in mantle, rock blanketed in crust, and still, here, there's no light. Only a slow, comforting warmth and a deep, ancient silence. It's almost like being inside a candle flame if the flame were a planet and the wax were time. At the very center, gravity pulls equally in all directions. You'd feel weightless, suspended, as if the entire Earth is holding its breath, and you are the quiet pause between heartbeats. And here's a sleepy thought to ponder as you float above that core. If the Earth has a heart, does it also have a pulse? Scientists have detected mysterious rhythmic tremors like planetary heartbeats on occasion. Very low-frequency vibrations that roll across the globe without obvious cause. Could they be echoes from deep within? The signature of shifting plates, the whisper of a spinning core, or something else entirely? So much we do not know. So much we may never know. And yet the journey downward, even if only in imagination, has value. Because by imagining the Earth's depths, you aren't just exploring the world. You're exploring curiosity itself. The Kola Borehole drilled only 12.2 kilometers down, barely scratching the surface. But your mind, your wonder, your quiet, sleepy awe that can carry you straight to the center of the Earth. No drill required, only stillness, only softness, only a gentle curiosity that asks what lies below the bottom. What story waits beneath the last layer? And in asking, you've already begun to understand. You hover now in the silence of the inner core, a place where movement becomes memory, and pressure holds everything still. All around you, the Earth's layers press inward, like the petals of an infinite stone rose. And you are its sleepy seed, cradled in warmth, far from the sounds of cities or storms. But let your thoughts begin to rise, slowly, gently, following the path of heat, itself outward, away from the core, tracing the journey that warmth takes, as it makes its long, winding climb toward the crust. This journey is ancient, because deep inside the earth heat is always escaping. It's not frantic or desperate. It's slow, methodical, patient. The core is like a softly glowing ember, and its warmth seeps upward through the mantle in convection currents drifting like slow lava lanterns in a planetary night. These heat currents drive the tectonic plates, shape continents, build mountains, split oceans. All that restless motion on the surface, the quakes and ridges, the volcanoes and trenches, is powered by the gentle, persistent escape of heat from Earth's deep interior. Imagine that heat now as a storyteller. As it rises, it whispers through the mantle, through mineral and metal. It carries secrets, clues to Earth's origin, to collisions with ancient planets, to the decay of radioactive elements like uranium, thorium, and potassium-40. These elements are the Earth's slow-burning fuel-releasing energy over billions of years. And here's something to make you blink slowly in the dark. Almost half of Earth's internal heat today comes from radioactive decay. Yes, the Earth glows from the inside because its atoms are still breaking down, shedding bits of themselves in invisible bursts, like sighs from deep time. You might ask yourself, what stories are those particles trying to tell? What ancient fires still flicker beneath the continents? Some of that heat never makes it far, but in special places it surges upward, quickly forming mantle plumes. These vertical jets of heat punch through the mantle like a slow-motion exhale, melting the crust above and creating hot spots on the surface. That's how the Hawaiian Islands formed one by one as the Pacific Plate drifted over a stationary plume, like drops of wax falling from a candle, forming a trail across the ocean. Or Iceland perched atop a plume, and a mid-ocean ridge, a land constantly refreshed from below. Even Yellowstone rests on such a hidden fire, bubbling away beneath its forests and geysers. These plumes are rare, mysterious, and immensely powerful. They're thought to originate from the core mantle boundary, making them like messengers from Earth's deep heart. What would a mountain say if it remembered being born of fire? And what would that fire say if it remembered its home in the core? You rise now with the heat drifting upward like smoke that never cools. As you pass through the mantle, transition zone, those minerals begin to change again, back from their denser high-pressure forms into more familiar structures. Remember, ringwoodite, that mineral so rich in hidden water. It lets go of its burden here, releasing moisture that might fuel volcanic eruptions or lubricate tectonic plates, making the surface more dynamic. Imagine that a single mineral, half a planet deep, playing a role in shaping continents. Eventually, the heat, and you reach the upper mantle, where the pressure eases and rock begins to behave more like rock. Not entirely rigid, not quite flowing, but ready to fracture and shift when nudged. This is the layer where tectonic plates begin their existence. Here, Earth is split into puzzle pieces, lithospheric plates that drift on the asthenosphere below, like rafts on a tar pit sea. These plates move slowly, just a few centimeters per year, about as fast as your fingernails grow. But over millions of years, that motion has rearranged the entire face of the planet. Pangaea was once a thing, a single massive supercontinent. And it broke apart not from violence, but from heat. That same gentle heat still drifting up from the deep, cracked Pangaea like the top of a cooling brownie. And one day, far in the future, another supercontinent may form again. Because Earth is never still. Even in sleep it turns. You drift higher still, approaching the brittle crust. And here the heat slows. It becomes less certain, less urgent. Most of the warmth never makes it all the way through. But where it does escape at volcanoes, at vents, on the ocean floor, at hot springs, it reminds us that the Earth is alive, not just on the surface, but in its bones. You reach a place now where your imagined journey meets reality. The Kola Borehole sits far above like a pinprick in a vast balloon. It never touched the mantle. It didn't stir the core. But it listened. It learned. And it revealed that even the crust itself, though thin, holds mysteries. So as you settle into the slow rhythm of rising warmth and shifting stone, ask yourself a final question for tonight. How much more lies below our feet than we ever imagined? A vast sea of rock-fire, metal, and memory. A planet with layers like dreams stacked inside each other. And at the heart of it all, something glowing, something ancient, something that doesn't need to be seen to be known. You've gone deeper than any drill, farther than any probe. And now perhaps you understand that the Earth isn't just a planet. It's a story still unfolding. You pause now in a place where stone softens and heat sighs right near the roof of the Earth's upper mantle. So close to the crust, you can almost feel the thrum of tectonic plates above you, grinding slowly, like tired giants shifting in their sleep. And it's here in this blurry boundary, between rigid crust and fluid mantle, that something strange happens. You begin to rise into the world of crystalline confusion. Because while we often picture the crust as solid, settled and well-behaved, it's anything but. It creaks, fractures, buckles, and under the right conditions it screams. Not in sound, but in seismic waves, ripples that reveal its secret cracks and histories. And at the Kola Superdeep Borehole, those cracks spoke volumes. As you drift upward toward the crust, where the real borehole ended, about 12,262 meters down, you begin to imagine what those final kilometers must have been like. The drill bit pressed forward inch by inch, but the rock behaved unexpectedly. Scientists had assumed they'd find a gradual transition from granite to basalt, but they didn't. Instead, they encountered crushed, fractured rock soaked with hot water, far more than expected, far deeper than expected. That water wasn't from the surface. It was trapped inside the rock itself, perhaps, for billions of years, freed by the intense heat and pressure. You can almost picture it now, ancient water, weeping out of stone, like tears from a dream too old to remember. And it makes you wonder how much water is hidden in the crust, waiting to be released. The crust, after all, is not a solid shell. It's riddled with fault lines, fractures, and folds. In some places, it's barely 5 kilometers thick, like under the oceans. In others, beneath towering mountain ranges, it swells up to 70 kilometers. That's thinner than the skin of an apple, compared to the whole fruit. And yet, in this paper-thin shell, all of life exists. The crust is where soil forms, rivers carve, trees grow. But beneath that fertile surface, it's mostly granite and basalt, igneous rocks forged in fire and cooled over eons. At the Kola site, they hope to reach the boundary where granite gives way to basalt, a marker called the Conrad discontinuity. But instead of a clear transition, they found a zone of metamorphosed rock. That means it had been changed, cooked, squeezed, stretched by immense geological forces over millions of years. It reminded them, and now reminds you, that Earth doesn't offer easy answers. Even the rules we think we understand where certain rocks should be can melt away like mist when we dig deep enough. The deeper they drilled, the hotter it became faster than expected. The temperature at the bottom reached around 180 digs, far above initial predictions. That heat made it harder to drill. The rock became plastic, almost putty-like. It warped the equipment. It made readings less reliable. It made you feel, perhaps, a little like you're walking through a kiln that dreams in layers. And even stranger seismic data, those tremors and echoes scientists use to peer beneath the surface, turned out to be misleading. What they thought would be there, based on sound waves bouncing through rock, was off. The lesson: even with modern tools, Earth keeps secrets. Ask yourself now, what else do we assume about the planet that might not be true? What quiet contradictions lie just beneath our models and maps? The Kola Borehole revealed microscopic fossils, more than 6 kilometers down, fossils of single-celled organisms preserved in ancient rock. That's life buried for 2 billion years, perfectly still in its stone cradle. Imagine holding a grain of rock that once touched the bottom of a sea that no longer exists, and finding within it a tiny spiral, a signature of something that once moved, once lived, and once shimmered in sunlight that will never shine here again. The drillers also encountered abnormal mineral zones, unexpected magnetic anomalies, and rocks that wept hydrogen gas, yes, hydrogen released from the Earth's interior, hinting at deep geochemical processes we still don't fully grasp. So much from such a narrow hole in the ground, so much from just 0.2% of the way to the Earth's center. It's humbling, isn't it? We live on this vast breathing world, and yet we've barely scratched its skin. We know more about the surface of the moon of Mars, even parts of distant Pluto, than we do about the landscape beneath our own feet. The crust is a place of transition, of stories half told, of materials caught between pressure and freedom, crystal and fluid, old and new. And yet it holds everything, every forest, every city, every memory we've ever made. Even now, as you float through this imagined journey, the crust carries you in its arms, like a gentle cradle, rocking with the rhythms of time. You feel it now, the shift of rock under your mind's feet, the drift of plates that seem still but never truly are. The crust is not just a layer. It's a boundary of belief between the seen and unseen, between the guessed and the known. And the Kola Superdeep Borehole. It was not a failure. It was a keyhole, a whisper, a reminder that the earth is stranger, deeper, more alive than we ever dared to dream. You emerge now from the crushing embrace of the mantle and into the uppermost layer of the earth's crust, where stone meets air and sunlight touches ground. But in your dreamlike ascent, you pause, suspended between depth and sky, to gaze back into the story that began far beneath your feet. The Kola Superdeep Borehole may have ended its physical descent in 1989, but its echoes still ripple upward. That narrow shaft, barely wider than your outstretched arms, opened a window into Earth's memory, one etched in minerals shaped by pressure and folded through time. And now it's time to walk along the crust. This is the surface we know best, or think we do. It's where the continents sprawl in their silent drift, where oceans sigh and rivers carve, where wind sculpts sand into soft dunes, and mountains rise like frozen waves mid-breath. But if you could peel back the oceans as though Earth were shrugging off a damp blanket, what would you see? Vast mountain ranges you didn't know existed, the mid-Atlantic ridge stretching like a spine through the seafloor. Deep trenches that could swallow Mount Everest and still have room for wonder, the Mariana Trench, nearly 11 kilometers deep, like a wrinkle in the fabric of the earth. And it all connects. Because the surface of our world is not a static shell, it's a jigsaw puzzle of tectonic plates drifting atop the mantle like enormous lily pads on a warm pond. The movement is slow, just a few centimeters each year, but its consequences are immense. The Himalayas are still rising, the Atlantic is still widening, and California, that sleep-deprived sliver of a state, is inching its way toward Alaska, one tiny shuffle at a time. You float gently above these restless plates, your perspective soft and wide. Beneath you, continents glide over timescales so long they might as well be dreams. And dreams, as you know, can change everything. It's here that the deepest borehole humbly sits, not in some exotic land of fire and ice, but in the Pechenga region of Russia, near the border with Norway, a place with permafrost tundra and silent pine forests, a place quiet enough to listen. In the 1970s, the Soviet Union wasn't just drilling, they were competing. The Kola Borehole began as part of a race, an echo of the space race, but this time aimed downward. The United States had Project Mohole, an ambitious plan to drill into the ocean crust, but it fizzled due to funding. Meanwhile, in a remote corner of the Kola Peninsula, a team of scientists and engineers kept going. They kept drilling and drilling. And when they hit 262 meters deeper than any other man-made hole in history, they made the Earth whisper secrets it had held for billions of years. You imagine standing at the rim of that borehole now, its surface long sealed, the metal cap grown cold. It's barely a circle, a shadow in the earth, yet it holds more mystery than many mountains. You might ask yourself, what's the value of a hole that goes nowhere? But maybe that's the wrong question. Maybe it's not about where it goes, but what it teaches. Because from that narrow cylinder of stone and data, scientists gathered insights that rewrote textbooks, that puzzled and humbled and delighted. And that still inspire those who wonder, those like you, what lies beneath. Among the findings, strange heat, inexplicable rock formations, unexpected seismic reflections. A sense that the deeper you go, the less you know. And perhaps most charming of all, a sound. Ah, yes, you may have heard of it, the screams from hell, as some tabloids claimed. In truth, it was nothing more than a misinterpreted audio file, spliced, manipulated, embellished. There was no shrieking at the center of the earth. Just data, just rock, just silence. But what a wonderful reminder of how easily myth clings to mystery. Because for every meter, drilled speculation filled in what science hadn't yet uncovered. Ancient civilizations, molten demons, subterranean cities, our imaginations drill even deeper than our tools ever could. And sometimes that's okay, because the truth, the real truth, is magical enough that we can peer into rocks that formed when Earth was just a newborn, when oceans were steam and skies were red. That we can study minerals that once sat beneath supercontinents, pressed beneath mountains, long turned to dust. That even now, with all our machines and measurements, Earth can still surprise us with its quiet complexity. You begin to sense that the story isn't really about a whole at all. It's about the Earth as a living archive storing heat and water, fossils and gases, all in its layered memory. It's about patience, geological, human, even yours. It's about listening closely to stone that doesn't speak in words, but in time. So you rest for a moment on the crust, your mind gently circling the layers below. You've traveled through pressure and silence, through mineral and myth. And now, as you gaze back across the journey, you ask the softest question of all. How deep does curiosity go? The answer, just a little deeper than we've ever been. Now, with your thoughts settled gently above the surface, you begin to drift not upward but outward, across continents, along fracture lines, over rift valleys and beneath deep forgotten seas. The Earth's crust, so thin and delicate from the cosmic perspective, stretches around you like a vast and rumpled quilt. But that quilt is restless. It crumples, it tears, it heals itself, slowly, patiently. And sometimes it breathes. It breathes through volcanoes' hydrothermal vents and geysers, steam and gas sighing from the deep earth. But even more quietly, it breathes through the slow exhalation of heat and hydrogen from the rocks below. That breath carries stories. The Kola Superdeep Borehole found that hydrogen gas escaped freely from the depths of the crust, seeping up from fractured rocks, whispering of chemical reactions still at work in the dark. Where did it come from? A combination of radioactive decay, water rock reactions, and perhaps some ancient biological processes long buried. It's a lovely thought, isn't it? That even rocks may remember the breath of life. And as you float across the crust, listening to these exhalations, you come upon something stranger, still deep biospheres. Yes, life down there. Not forests or whales or fluttering birds, but microbial communities living in complete darkness, subsisting off chemical energy. No sunlight, no surface interaction. Just heat, minerals, and perseverance. The deepest life ever discovered lives around 5 kilometers beneath Earth's surface. Tiny bacteria clinging to cracks in ancient rocks, slow to grow, hard to reach, impossible to ignore. Ask yourself, how many forms of life have we never met, simply because they're too small, too deep, too quiet? In the borehole samples, fossilized microplankton were found embedded in metamorphic rock at more than 6 kilometers deep. Organisms from a time when the crust was young, trapped forever in stone. You try to imagine them floating once in prehistoric oceans, catching the golden light of a sun that looked much the same, then slowly sinking, buried under pressure and time. It's humbling, and it gently reframes the question, The borehole didn't just go down, it went back. Back through eras of shifting continents and exploding volcanoes, back through supercontinents like Rodinia and Pangaea, back through the great extinctions and surges of life. Each meter was a museum layer, a ribbon of memory. And the rocks, they remembered it all. They remembered when oxygen first flooded the atmosphere around 2.4 billion years ago, and the world turned from rust-colored to blue. They remembered when ice covered almost everything, and when forests grew tall in what's now Antarctica. The deeper you go, the more ancient the rock becomes. At the bottom of the Kola Borehole, the rocks were over 2.7 billion years old, formed when Earth was less than half its current age. Pause with that for a moment. Imagine pressing your hand to a wall that formed before trees existed, before the moon had finished drifting away, before fish had jaws. Now you ask yourself softly, can we ever truly comprehend such age? Our lives, our cities, even our languages, they flicker and vanish in the time it takes a mountain to blink. And yet we keep asking. That's the beauty of this whole story. That even when faced with stone so ancient it seems eternal, we still reach for understanding with our gentle human minds. The borehole didn't deliver a prize or treasure or core of gold. It gave us something quieter, humility. It reminded us that the earth is not fully knowable, not completely charted. There are boundaries we may never cross, depths we may never touch, not because of lack of will, but because the planet herself decides what to show and what to hide. Still, we dream of reaching deeper. Projects are underway in quiet corners of the globe to drill farther through volcanic rock into tectonic boundaries down toward the mysterious Mohorovičić discontinuity, or MOHO, the boundary between crust and mantle. No one has ever reached it. But it calls to us, doesn't it? Like a faint hum at the edge of perception. The Kola Borehole didn't reach the MOHO, but it brought us closer. It showed us that our maps are estimates, our models, approximations, and our planet full of quiet surprises. And that makes you smile, doesn't it? That even here, wrapped in a blanket and drifting off to sleep, you can touch the edge of a story so old, so vast, and still unfolding. As you settle deeper into this dream of stone and time, remember the earth does not give up its secrets easily. But sometimes, just sometimes, it whispers. And when it does, you can hear it, not with ears, but with curiosity. The deeper you drift into this subterranean reverie, the more clearly you sense the rhythm beneath Earth's skin, not just heat and stone, but motion, memory, and mystery. And at the center of that mystery, pressure. Down there below the borehole's final breath, the pressure mounts unimaginably. At the depth of the Kola Superdeep Borehole, 12,262 meters, the pressure is estimated to be over 4,000 times atmospheric pressure. The rocks press in on each other like slow dancers, locked in an eternal embrace. The deeper you go, the more they resist. And yet, they whisper. What do they whisper? They tell stories of metamorphism, of rocks transforming under heat and pressure, of ancient sediment turning to schist and granite being reborn. These are not the violent metamorphoses of myth, but the quiet, patient shifts that take millennia, perhaps millions of years. You imagine a single grain of quartz tucked in a crevice 5 miles deep. At the surface, it was ordinary, crushed from a mountain, tumbled by rivers, carried by wind. But down here, it's changing. Its crystal lattice subtly bending minerals, realigning like dancers, finding a new rhythm in a tight space. These rocks are not passive. They push back. In fact, one of the reasons the Kola Borehole had to stop was rock flow. The deeper the team drilled, the more the surrounding rock closed in, as if trying to seal the wound. Like the earth herself was sighing, that's far enough. It's strangely comforting, isn't it? that even the crust has boundaries it wishes to protect. But not all resistance is hostile. Sometimes it's just tender. You picture the drill bit descending slowly, humming through layer after layer, and the rock folding gently around it like a deep breath. This wasn't destruction, it was a meeting. The machinery like an ambassador from the surface world, coming to shake hands with the underworld. What did the rocks say in return? Through temperature for one. At the bottom of the borehole, the temperature was far higher than scientists had predicted, over 180 degrees Celsius, much hotter than expected at that depth. This excessive heat complicated everything. Tools failed data, blurred timelines stretched. But heat is information too. It speaks of radioactive decay, of friction and depth, of the planet's slow exhale from the inside out. And it makes you wonder, how warm is the beating heart of a planet? How close is too close to touching it? Even now, with advanced technology and decades of hindsight, we struggle to answer those questions. Because the Earth does not offer clarity, it offers layers. Not just physical ones, geological, mineralogical, but emotional layers too. Wonder, awe, patience, humility, and always, always more questions. Take the seismic mystery the Kola Borehole helped illuminate for years. Geologists believed they would find a layer of basalt deep in the continental crust. Seismic readings had long suggested a shift at a certain depth, a basaltic boundary. But the borehole passed that depth and found granite, metamorphosed, dense granite, not basalt. The seismic boundary wasn't a new layer of rock, it was a change in the same rock's properties, compressed and transformed. What they thought was a new substance was simply a new version of something familiar. Isn't that a lovely metaphor? That something you think is completely different might just be something you already know, shaped by time and pressure. It invites you to reflect. What else in your life feels foreign, but is simply a familiar part of you seen from another angle? That's what the Earth teaches when you dig deep, not just facts, but perspective. Because depth changes everything. It changes stone, it changes temperature, it changes light into darkness, and pressure into metamorphosis. And it changes you. When you've stood at the threshold of such silence, such age, such enormity, you carry that quiet with you, like slipping a smooth pebble into your pocket, a souvenir from the underworld. And now you rise slowly, through cooled granite and crustal fractures, through metamorphic folds and fault lines, back toward daylight. But you don't leave empty-handed. You carry questions like lanterns. You carry images of hydrogen gas gently escaping fractured stone. You carry the thought that somewhere miles below your feet, a tiny bacteria is going about its day, utterly unaware that it lives deeper than any other creature known to science. And you carry the knowledge that even now we've barely scratched the surface. So much still waits. The moho boundary, the mantle's roiling mysteries, the secrets locked in super deep diamonds carrying whispers from 700 kilometers down. You're floating toward the surface now, but your mind lingers just a moment longer in that pressurized stillness, where time and temperature bend the rules, and even the rock listens. Because you know you'll return again, maybe not in metal, or drills, or funding, but in dreams. And dreams, after all, are how we keep digging. And now you drift just beneath the crust, high above the borehole, but still deep below the skin of cities, forests, and oceans. You hover like a curious thought in Earth's subconscious. And that's when the final truth arrives, as soft as a feather landing in snow. The Kola Superdeep Borehole was never just about rock. It was about reaching. In 1970, when the first meter was drilled, there was no promise of treasure. No rich ore, no glowing core of fire, just questions. And scientists with pencils in pockets and dreams in hand asked those questions with drills instead of words. It became a decades-long conversation with the planet herself. And like any long conversation, it had surprises, dead ends, miscommunications, and moments of breathtaking clarity. At over 12 kilometers, this borehole remains the deepest man-made hole ever drilled into Earth's crust. If Mount Everest were dropped into it, its peak would still be buried under a mile of rock. That depth is staggering. But even more staggering is this. The crust, on average, is between 30 to 50 kilometers thick beneath continents. The Kola Borehole didn't even get halfway, not even close. After 24 years of drilling, the team had to stop. The heat, the pressure, the slow, unrelenting creep of rock. It all said this far, and no farther. But that's okay, because sometimes wonder doesn't require completion. It only asks for the effort. And in the effort, we learned so much. We learned that the boundary between granite and basalt, once believed to be a solid geological line, was a mirage, a misreading, a signal bent by pressure and depth. It was granite all the way down, only transformed by the weight of ages. We learned that hydrogen gas seeps freely from the depths, whispering of chemical reactions still bubbling in the dark. Not violent, not dangerous, just quietly, eternally alive. We discovered tiny fossils millions of years old, embedded deep in metamorphic rock remnants of ancient life that once floated in primeval seas. They fell through time like snowflakes, landing in layers that became something else entirely. We found water, trapped in crystal lattices, under more heat and pressure than any ocean could dream of. Liquid in the unlikeliest of places. And perhaps most beautiful of all, we proved that curiosity has no bottom. You imagine the moment the drill fell silent. The hum gone. The work paused. A crew of scientists staring into the narrow shaft, barely wider than a dinner plate, knowing they'd touched something no one ever had. That tiny portal into Earth's inner memory. And what did they leave behind? No plaque, no monument, just depth and questions. What happens if we go further? What if we reach the moho, the place where crust becomes mantle? What if the mantle isn't what we think it is? What if it's warmer, wetter, stranger? These questions don't keep you up. They gently rock you to sleep. You start to feel it now, don't you? That comforting sense that the planet beneath your feet is not just a platform, but a companion. Breathing, shifting, remembering. She remembers the impact of asteroids. She remembers when oxygen first laced the air. She remembers when the continents danced together as one. She remembers every quiet footstep that ever landed on her surface, and every hopeful drill that dared to push deeper. And now, as you lie still listening with your whole self, you realize you're part of that memory too. A flicker in the timeline, a soft sigh in the dark. And somehow that's enough. You don't need to reach the center of the earth to be changed by it. Just listening gently, curiously, is more than enough. So now, with your mind soft and open, like freshly fallen snow, you float gently back to where you began. The hum of the drill fades. The rustle of rock gives way to silence. And the light, if there ever was any down there, dims to a deep velvet hush. You've gone farther tonight than most people ever will. Down through granite and gneiss, into the pressure-wrinkled folds of time past, layers born before dinosaurs, before forests, before even the first breath of oxygen filled the skies. You've touched the edge of what we know, and felt the weight of what we don't. And now that knowledge rests with you like a warm stone cupped in your palm. Nothing flashy, nothing loud, just solid, ancient, still warm from the inside of a planet that's been here for 4.5 billion years. It's okay to let it go now. Let the questions drift. Let the pressure ease. Let yourself sink into this quiet, because sometimes the deepest discoveries happen not when we're searching, but when we're still. If you've enjoyed this journey, I'd be quietly grateful if you'd give this video a like or tap that subscribe button for more peaceful explorations with the sleepy scientist. It helps more than you might imagine. And before you drift off, I'd still love to know, where in the world are you listening? From what time it is there? Leave a comment if you're feeling cozy enough to share. It's always a quiet joy to see this sleepy little community ripple across time zones and continents. Good night, sweet dreams.